All right. In this video, we're going to take a look at hypothesis testing using confidence intervals, specifically, again, for when we're dealing with averages, So we're going to be dealing, again, with kind of a combination of this hypothesis test box and this 8.2 confidence interval box. Let's see how this is going to work. It's very similar to what we did in the last section. All right. Example 6. A company that produces ball bearings conducts frequent quality control checks to make sure that the overall mean diameter of the ball bearings must be 4.300 millimeters. A sample of 81 ball bearings had a sample mean of 4.299 millimeters, and a standard deviation of the diameters of the ball bearings is 0.005. Test the claim that the overall mean diameter of ball bearings is not 4.300 millimeters. Okay, again, this should be fairly easy to approach because it's very similar to hypothesis tests that we've done previously. So what I have here is two hypotheses that I can set up. And if I'm interested in that last sentence, which says I want to test the claim that the overall average diameter of the ball bearings is not 4.300, then that seems like a perfect alternative hypothesis, which means that my regular hypothesis, the null, has got to be 4.300. Perfect. So I got this set up. I can then go to my conditions, where I'm going to list out my evidence and check the conditions to make a confidence interval for mu. So let's see, evidence. I can see here N. We tested 81 ball bearings. There was a sample average of 4.299 millimeters, and there was a standard deviation of 0.005. Great. I can now also do the checks. And this check here is really easy. I can start to see immediately that N is greater than or equal to 30, so boom, I'm good to go. So now I know I can safely build a confidence interval. Again, the difficult part here is I don't know what the confidence level should be because the problem never told me that. But I do know that there's an alpha given to me in this problem. Now, it might seem kind of weird, like, wait a minute, Kyle, where was the alpha given in the original problem? Does it really say anything up there about alpha or the level of significance? It really doesn't. But if the problem doesn't state, then it's always customary to assume that 5% is what you've been given. Okay, so we're going to assume that we have 5%. That's just standard. Just like back in the previous exam, we asked, what does it mean for something to be unusual? We said under 5%. That's our default. If the problem doesn't change that, we always go back to it. So since this is a two-tailed test, you might remember we did this before. When we looked at our x bars that lined up on a number line, and they have a t-distribution, which kind of looks like a normal, we said that in a two-tailed test, both sides need to be shaded. And that means that this alpha value of this bad 5% has to get split between the two tails. So that would mean then that the interval that we construct is going to have to cover what percentage of the associated distribution. Well, yeah, it seems like this would have to be 95%. So now I could go to my calculator and I could actually build the interval. Let's see what we come up with. Go to my calculator. I'm going to click on Stat. I'm going to go to Tests. I want to create, again, an interval. Interested in doing a t-test. I want to create the interval here to answer the question. I kind of have stats listed out. My sample average was 4.299. Standard deviation was 0.005. N was 81. And we want a 95% confidence interval. So the interval that we end up with here is 4.2979. 4.3001. And again, I need to keep in mind that the hypothesis that I'm trying on right now is H0. So H0 said that the actual average is going to be 4.3. And we're saying we're 95% sure that whatever the average actually is, it's somewhere between these values. So the question is, how well does H0 fit? Is 4.3 a reasonable value? Does it fall inside of our interval? And if you take a look here, it just barely falls inside of this interval. It is so close to this right edge, but it is inside. And so I would go ahead and say, yes, it is inside. My conclusion then would look like, since the interval does contain the believed value of the mean being 4.300, we do not reject H0. H0 still seems like it fits pretty well. So I'll say here, we have no reason to doubt that the average ball bearing diameter is 4.300 millimeters. I don't have any reason to doubt that at the moment. Still seems like that's a reasonable claim to make based on the evidence. Okay. There is one more example that is in this section. It's number 7, and it's one that I would have actually left for you to complete in class. So what I'm going to ask you to do is to go ahead and try to work through that example. Check the solutions up online to see if you actually worked through it correctly. And if you have any questions, feel free to email me or visit me during our virtual office hours. Okay? That concludes then section 8.2, and in the next couple videos, we'll be jumping into chapter 9, where we'll take a look at how do I conduct a couple more hypothesis tests, both in this kind of, in the original traditional approach with p-values, and also in this confidence interval approach.